Here are some of my experiences in trying to find a complete machinery for fermionic behavior. I suspect fermionic behavior to be the most challenging one, as it defies our human intuition. Other specific behaviors are attracting and repelling charges, entanglement, and the concept of mass. In my opinion, entanglement, mass, and gravity can be most easily explained by space-time capital. The elastic fabric as complete machinery. Stretching and warping are enough to be a provider of gravity. Any extra more complex distortions, called elementary particles, will add to the stretching and warping. Large-scale distortions may be called dark matter. Entanglement is naturally available. Everything is shaped in one fabric. Entangled is the perfect word to describe this moving unity of imagined objects. For charge, we seem to need mirror symmetry and wave phase symmetry. Torsion in a left-handed and right-handed manner can distinguish plus and minus charges. Resonance carrier balls seem equipped to provide such torsions and wave phases. And then there is the pièce de résistance of creating SU2 symmetry for half-integer spin in the geometry of space-time capital. We need actual geometric shape and shape change. My bet would be on an RCB with internal distortions of the belt trick kind. As in the previous Part 2 clip, an impression is shown of the belt trick with many belts. Visualize to extend the belts into a continuum of belts. The inside of the RCB becomes this continuum of belts. The inside of the RCB is of course just made of the fabric of space-time capital, just like everything else. Other mechanisms to mimic half-integer spin symmetry are not yet excluded, obviously. Think of resonances in, on, and around the carrier ball. Initial experiments with superpositions of Legendre polynomials hint at stable torsions in the fabric. In fact, that's how the idea of an RCB started, a long time, some 20 years ago. We want an elastic fabric to move by itself, and we want to simulate behavior that we recognize from reality. There's one barrier in realizing dynamic behavior and a dynamic experiment. It seems to me that this barrier might be nature's final way to keep us humble. I do not rule out the possibility that it cannot be done, even though a gut feeling tells me otherwise. In the computer, two time slices, a so-called Markov chain, are connected to simulate movement in space-time capital. One time slice represents spatial information. Two related time slices add change and velocity to each individual point. Calculating the next time slice simulates a fabric that, if projected on a computer screen, behaves like you would expect something elastic to behave. This all looks very natural. The barrier, the problem and major limiting factor is also very natural. How do you shape the time 0 slice and time 1 slice for some shape to exist for a longer time without falling apart? Two time slices of space geometry is all you have to construct virtual reality. All the behavior is in there and in the algorithm that calculates the next slice. An RCB can be shaped in one time slice, but a moving resonating RCB is constructed in two time slices. It's like throwing a pebble in a pond. The initial imprint in the water distributes in concentric circles away from impact and sort of disappears. This is exactly what you see happening in the virtual elastic space-time capital. Random shapes can come into being and exist for a while, but to control those shapes is in my opinion the greatest challenge. I have never gained control. I have no control over my elastic space-time capital. My hope is that someone young can make progress with the help of perhaps one or even a few artificial pattern recognizers, one checking the other. Together, man and machine may be able to do numeric experiments, experimental behavior mimicking real-world behavior. For instance, two RCBs simulating two electrons repelling. With respect to electromagnetism and gravity, Pierre Millet has had algebraic and geometric successes. Some of his work is in the description below. However, his approach of tearing and gluing an elastic space-time to generate fermionic behavior lacks a complete machinery, in my opinion. There just aren't any properties available to the material that initiate or facilitate tearing and re-gluing. There's also no description of the process of tearing and gluing, and there's no description of what is in between the torn material. There's no how or why. His fermion remains an algebraic construction on paper, yet is not by itself changing material. Here, mathematics still seems limited. We need new layers of description for emerging shapes and behavior of space-time. It seems mathematics has never considered to go there. Nevertheless, a remarkable and beautiful alternative, but who am I to say this? I think that the initial way is through numerical analysis. The algebraic and geometric mathematical approach will probably only be able to take over after numerical success. Constructing an RCB completely shaped and moving in elastic space-time capital is the initial task. Too difficult for me. Hopefully someone else, or likely a team, will come along. Constructing shapes and interpreting shapes, adding the scientific perspective. Generating fields and interactions from space-time capital as an analogy to reality, where there are no forces or distinctions. We need forces to explain relations between our distinctions. Fingers crossed